Got it. And I should be able to stop also. So we're gonna do this more like I do class. Let's see. So you should be able to see this. So here we go. Here's the tech. So what we're going to be doing is we're going to be going through questions, and I'll go through some of the question. There's always going to be an opportunity. I'm going to pause the recording so you don't have to worry about asking a question and it being recorded, because I'll always pause it. If you have no problem asking questions when we're being recorded, then ask questions at any time. Not a problem at all. Yes, the recording, and Jordan, you might know the answer to this, where the recording is posted
Mhm.
afterwards. Is that just being sent out in announcements through their own class, or?
They should be linked somewhere in the course according to what Debbie said, but I don't know if Debbie's using a shortened link or anything like that, but it's where you find that live meeting schedule, that document that had the live meeting schedules.
Okay, so it should be posted. I'll take a look through my email and see if I can find where the
I mean,
links
I have
are
the
to the
link to it,
recording.
but I don't know if Debbie wants them to go through a shortened link or not.
Okay. All right. So and you're Math 136 instructor. So I'm actually not even teaching a Math 136 online this semester. So your personal instructor will have those links available to you. I don't know if they're posting it in their announcements. That's probably the most likely spot that they're doing it, is the announcements. You should probably have an announcement to that link. So hopefully that helps answer that question. I'll look through an email to see if I can find a link to those recordings. It should have been actually attached to the email that you got for this link. However, you got this link, should be a good place to do that. All right, so great. So I want to welcome everybody first. So Caitlin, Dr. Haram, Kip, Matthew, Nick, and it's Tisha. It's just Tish, actually. It's just Tish. So what we're going to be doing, this is how I start every single class, is we're just going to start with whatever questions that you have. So the lecture series this week, the instructor on Wednesday went over the earlier part. The instructor yesterday went over the middle part. We're going to be covering sections 5.3 and 5.4 today, which is over it's over transformations and rational functions. Okay, so I have some problems picked out that I'd like to go over on the homework. But if you have questions on the homework, first, we can do that. And you can use the chat. You can unmute yourself. This is different than last week. It's better than last week. The chat function actually works. Everyone should be able to chat. If you want to ask a question personally, instead of to everyone in the chat box, just put to Paul, and I can go over that question. So if we all want to follow along, if you want to go ahead and log into your MyMathLab, I'm going to be doing question 20. So we're going to be in homework 03B, question 20. All right, so we're going to do this. So I'm going to stop sharing here. We're going to start sharing. Here we go. So I just used Paint to go over the problems, but I'm going to copy paste the actual problem into Paint so you can see it. So we're on homework 03B, number 20. We're going to start out with number 20 here. All right, perfect. So we're going to talk about transformations here, and this is a perfect problem to do transformations on because it has all three parts. Okay, so in fact, we're going to write out here, this is homework 03B, number 20. Okay, and we're going to be talking about transformations. Okay. And so this is a really, really big, wide topic. And we have an hour, so we go through it pretty quickly. But if you have questions at any time, please, please, please let me know. So we're going to write out this. Well, it should be a function, but that's okay. It is a function, but doesn't specifically say f of x. So it's y equals 5 times x plus 2 squared minus 3. Okay. And when we're doing transformations, what we're doing transformations is we're always going to have a parent function. Okay. So there's always going to be a parent function. All right. And previously, it should have been a library of functions. That's what they call it. You would get an idea of what some graphs look like. So we know what like f of x equals the absolute value of x looks like. You should have a rough idea of what that looks like. And it's just a V shape. Okay, so f of x equals the absolute value of x is just a V shape. This should be a little bit of something that probably was gone over earlier in the week. F of x equals the square root of x. So what does the square root of x look like? We should just have a general idea. We don't have to be perfect. These are your parent functions. When we are talking about transformations, these are our parent functions. Okay. That's pretty bad. It's a parabola, but that's okay. All right. And then we've got like x cubed. We have quite a few parent functions that we should know the shape of, what they look like. We can scroll down some here. F of x equals, and then a big one is 1 over x, which is what we'll talk about later in the class, which is why I just called it a big one here. So this is our graph of 1 over x. Okay, so for our purposes, the one that we have is an exponent of 2, which is going to be a parabola. All right, perfect. So this is question. Oh, so we got x squared right here. This is the one we're going to be using for us right now. And this is one, the bottom one is what we're going to use later. So I'm just emphasizing those two because the one in green we're doing right now, and the one in purple we're going to do later. Okay, so those are the two important ones for this one. And Nick, yes, absolutely. We're going to do 34 right after this one, although we might make a pit stop at 27 first. All right, great question. Yeah, we'll go over that one. All right, so transformations. A transformation are your adding, subtracting, multiplying, or dividing. Those are your transformations, okay? So in this case, let's color code our transformations. Let's make our transformations orange. So the parent function is in green. The transformations are going to be in orange. We have a +2, we have a -5, and we have a -3, okay? So the way we do transformations, there's two types of transformations. The way I describe it either belongs to the x or it belongs to the y, okay? If it belongs to the x, it's inside the parentheses. Or if you're being more mathematical about it, you'll say it's inside the parent function. Okay? It's inside the parentheses or it's inside the parent function. So let's color code the belongs with x in blue. This +2 is inside the parent function because you're taking the x +2 and you're squaring it. So this +2, we say belongs to the x, okay? If a number belongs to the x, it only affects x values. It only affects x values, okay? And it always does the opposite of what you want. So what do we mean by opposite? Instead of adding 2, what's going to happen is, right, instead of adding, well, how do we write that in a consensus way? It does the opposite. So add becomes subtract. Multiplication becomes division, right? And it only affects the x values. And the x value is the horizontal asymptote. So it always affects things horizontally. Oh gosh, horizontally. that good enough? Horizontally, something like that. Only affects it horizontally. Okay. The big things we want to remember is if it's on the inside of the parent function, if it's on the inside of those parentheses, it belongs with the X. If it's on the outside, it's going to belong with the Y. If it belongs to the X, it only affects X values, which means it's only affecting things horizontally. And then it doesn't do what you want. If it says +2, it doesn't add 2, it subtracts 2. So what's going to happen is this +2 is going to move it to the, you want it to move it to the right, because +2 horizontally, you want it to be to the right, but it does the opposite. It's going to move it to the left. It's going to move it to the left 2. Okay. Let's do some that belong to the Y. We'll use pink. Can we see pink? Not really. Let's use brown. All right. This -3 and this 5 belong to the Y. If it's on the outside of the parentheses or outside of the function, it's going to be, outside of the parent function. It's going to belong with the Y. If it belongs with the Y, it only affects Y values. If it only affects Y values. Oh, and it always does the same. So if it is a addition stays addition, right? So plus stays plus. Okay. And in fact, let's separate these. It's a little hard to read. All right. Plus stays plus. And then we've got, it's only going to happen vertically. All right. It only happens vertically. So on this problem, this -3, it's on the outside of those parentheses. If it's on the outside of the parentheses, it belongs to the Y. If it belongs to the Y, it only impacts vertically. And it does what you want. Down 3 is -3. Okay. So we call addition and subtraction. We call addition and subtraction a shift. We call multiplication a stretch. And we call division a compression. And these are the end results. If the end result is division, which means that after you take the opposite, if it's division, then it's compression. Okay. All right. We're actually going to pause it here, see if there's questions. All right. So this 5 is on the outside, which means it belongs to the Y, and it's multiplication. It's 5 times X plus 2 squared. So this is going to be, it belongs with the Y and it's multiplication. So it's going to be vertical because it belongs with the Y. It's a vertical stretch by 5. It's a vertical stretch by 5. All right. That finishes this problem up. What I'd like to do now is just do a bunch of these really fast. All right. So that's what I'm going to do. We're going to do a bunch of these really fast. And we'll see, we'll get maybe a little bit of participation here. So let's do the function f of x equals, and let's do absolute values. So let's do the absolute value of 2x plus 3, the absolute value of 2x plus 3. Okay. So I'm going to pause here. All right, so this problem has 2 transformations. We have 2, right? And the 2, what would we say? We'd say that this is on the inside. If it's on the inside, it belongs with the X. Well, what is that 2 doing? It's multiplication by 2. Since it belongs with the X, we do the opposite. Since it belongs with the X, we do the opposite. So instead of multiplying by 2, we're going to divide by 2. And division by 2 is a compression, right? And it belongs to the X, so it's horizontal. So it's a horizontal compression by 2. Okay. And then our second transformation is this plus 3. The plus 3 is on the outside of the function. It's on the outside of the absolute value sign. So if it's on the outside, it belongs to the y. Adding 3. But with the y, we do the exact same. So what's going to happen? We're going to go up 3. Those are our 2 transformations. Now, if you are doing this, if you wanted to graph this real quickly, you start out with the original graph. You follow order of operations. So order of operations says, do multiplication and division first. So we need to horizontally compress this thing. All right. What is a horizontal compression? Well, you take the sides and you push them in. You're compressing them horizontally. You can think about compressing horizontally. If you've ever seen Star Wars and they're caught in the trash compactor, that trash compactor is going to squish them horizontally. Okay. And what's the end result of squishing them horizontally? It gets more narrow, gets thinner. Okay. And then after you do the multiplication division, you do the addition and subtraction. We got to go up 3. So from here, we go up 3. 1, 2, 3. Okay. Every point goes up 3. Look, it doesn't have to look perfect because what you're doing on these is you're selecting the graph. If you're told to graph, you're selecting the graph. But a lot of times you're just going to be asked to write out what's happening or to select the multiple choice of what's happening. All right, let's pause here. Let's see if there's any questions. Any questions on this? All right, so here we're going to have a hand-picked transformation. We're going to do f of x equals -2 divided by x minus 3. So on this one, we want to know what the parent function is. The parent function is 1 over x. All right, and what 1 over x looks like is this. 1 over x looks like this. Okay. So we have quite a bit going on here. We have 3 transformations. We have a negative that's being multiplied that I haven't talked about yet, but we'll do now. We have a 2 that's on top, and we have a 3, a -3 that's on the bottom. Okay. So I think what we should go with is what we know. This -3 is on the inside of the function, right? It's in the parentheses, it's with the x. So this -3 belongs to the x. And if it belongs to the x, we do the opposite. So instead of -3, we're going to add 3, and we're going to do that horizontally. Okay, we're going to do that horizontally. This shifts it to the right 3. So we're going to take the whole graph and we're going to shift it to the right 3. All right. Well, let's deal with the purple next. This purple is a little bit confusing. It's multiplication by 2. It's multiplication by 2, and it's on the outside of the function. How do we know it's on the outside? Well, it's not inside the parentheses. That's a good way to know that it's on the outside. How do we know it's multiplication? Well, if we take 2 times 1 over x, we get 2 over x. So that's a good way to know that it's multiplication. All right, so it's multiplication by 2 on the outside, which means if it's multiplication by 2 and on the outside, it belongs with the y. And if it belongs to the y, everything that happens is done vertically. All right. And so this is a vertical stretch. It's a vertical stretch by 2. This one is a vertical stretch by 2. All right, I'm going to pause here, see if there's any questions. All right, so the last thing we're going to take care of is that negative sign. That negative sign is multiplication by a -1. And this one we handle differently. It belongs with the y for the same reasons that 2 belongs to the y. So it's multiplication by -1 on the outside. So we have multiplication by -1 that belongs with the y. And if it belongs with the y, it always happens vertically. So what we call this, anytime you multiply by -1, we call it a reflection. It's a reflection that's happening vertically. Okay. So we need to do all three of these things on our parent function. So our parent function, we're going to do in green. All right. I didn't do the greatest job, but it's decent enough. We're going to reflect this vertically. So the orange is a reflection vertically. What's that mean? The stuff on bottom gets reflected up top. So it's going to look like this. The stuff on top gets reflected to the bottom. It's going to look like this. Okay. I'm not doing a perfect job here, but hopefully you get to see. You're just picking the right multiple choice one. So as long as you get it in the right ballpark, you're going to know which one it is. Oh, and why are we doing this first? We're doing the reflection first because order of operations says do multiplication and division before you do addition and subtraction. That's why we're doing that. So now let's take care of the purple. The purple is kind of really hard. It's a vertical stretch by 2. So we're taking every point and we're stretching it. We're doubling the y value. It's pretty hard to draw. We don't have to be perfect. Okay. We just stretched our y values. We stretched our y values. All right. Not perfect in any stretch of the imagination. Stretching it vertically is a little bit tough. You double the y values. You double your y values. That's what you do to vertically stretch it. Take the point, grab it, pull it up. And then the last thing we do is we subtract. Oh, no. We're going to the right 3. So I'm going to put it on its own thing here. So that's going to be in blue. We're going to take the purple graph and we're going to move it to the right 3. So this is where our asymptotes are now. Our asymptotes are now at x equals 3 and y equals 0. And then vertically stretch it. So if we vertically stretch it, it'll look except I'm in the wrong quadrant, right? We're in the 4th quadrant and the 2nd quadrant. So it'll look something like, oh, that's bad because I didn't go all the way. Looks something like this. And again, not perfect by anyone's stretch of an imagination, but it doesn't have to be perfect. The things that are going to change on the multiple choice, if this was multiple choice, is the asymptotes. So the asymptotes are going to change. They're not going to they're not going to trick you by you didn't stretch it. They're not going to trick you like that. All right, we're going to pause here, see if there's any questions. So we're still in homework 03B. This is homework 03B. This is number 34. And it says find the vertical, horizontal, and oblique asymptotes, if any, for the given rational function. This is an awesome question. This is an awesome question. All right. So if we want to find vertical asymptotes, the first thing we should try, right? You should try to factor. Okay. This one's a really rough one to try to factor because the top is pretty rough. 10, the way I factor is you multiply the first and the last. So we need 2 numbers that multiply to -70. Oh man, are they mean? And add to 33. Okay. So -70 is 1 and 70. One has to be negative. Since it's positive, the bigger one has to be positive. That gives us 69. Let's try 2 and 35. -2 and 35 is 33. This thing factors. This thing factors. Okay. Not friendly. So what we do is once you find the pair of numbers, you rewrite the middle. Okay. If you are guessing and checking, you can guess and check. This one's a hard one though to guess and check for sure. So I would always do this by factoring by grouping. So we're going to have 10x squared and then replace the 33x with -2x. Let's color code it. Let's color code it. We're going to color code it. We are going to replace the 33x with -2x plus 3x. So it's going to be -2x plus 35x, right? And then we complete it with the -7. Okay, I'm pausing here. All right, and I'm just going to copy paste one more time just to make sure that on the recording students can see these. And if you have any questions, always, or you want more videos, I'm going to put my email in chat as well. I have a ton of these made, and that's just me. That's me doing the problems. Okay, so I know sometimes I do things a little differently, you know, that's okay. What's nice about this method is it always works. And when it doesn't work, you know that it doesn't factor. So that's what I really like about it. Sometimes guessing and checking, you feel like you guess and check forever and you don't get anywhere. So, all right, let's continue on. Let's continue on. Now we factor by grouping. We group the first two terms and the last two terms. So the first two terms, they're both divisible by 2 and they're both divisible by x. We take out a 2x and we're left with a 5x minus 1. And then because this is a plus sign, we put a plus sign. We don't factor out a negative. And then they're both divisible by 5. So it's going to be 5 times 5. They're both divisible by 7. 35 is divisible by 7. So we get 5x minus 1. And now we factor by grouping one more time. We take out a 5x minus 1. And we are left with a 2x plus a 7. That's what we're left with. That's how the top factors, okay? When we put that in the top, it becomes f of x equals 5x minus 1 times 2x plus 7 divided by 5x minus 1. And now what happens is, instead of 5x minus 1 equals 0 as an asymptote, these will cancel. And when those cancel, you're going to say that there's a hole when 5x minus 1 equals 0. This problem doesn't ask for holes, so in the red, I don't care. All I care about is finding the vertical, horizontal, and oblique asymptotes. Because there was a hole, our function actually looks like 2x plus 7 with a hole when 5x minus 1 equals 0, which means there are no vertical asymptotes. Because the way we find vertical asymptotes, to find vertical asymptotes, you set the denominator equal to 0. That's how you find vertical asymptotes. Because there is no denominator on this problem, there are no vertical asymptotes. Okay. So on the first question, we would say, I don't know what I just said. We would say the function has no vertical asymptotes. And then a horizontal asymptote. A horizontal asymptote would look like y equals 5 or y equals 3. Ours looks like ours is y equals 2x plus 7. This is an oblique asymptote. An oblique asymptote has a slope. If it has a slope, not equal to 0. So this slope is 2. Anytime in your problem you have a slope, it's not equal to 2, right? Because y equals 5 has a slope. The slope is 0. That is an oblique asymptote. So when we're going through this problem, in fact, I'm going to stop sharing here and I'm going to share the homework problem. We're going to share the homework problem right here. We would say C and then check our answer. All right, we did it. We got it right. The function has no horizontal asymptotes. Check our answer. Good job. Then the function has one oblique asymptote. It's going to be 2x plus 7. 2x plus 7. So that way you can see it, because sometimes entering the homework is a little cumbersome. 2x plus 7. And actually, we probably have to put y equals 2x plus 7. All right, there we go. Okay, let's pause it here. Let's pause it here, see if there's any questions. All right, so we're doing homework 3B, number 44. First thing we got to do is factor. This does factor. So x squared minus 9x minus 10. This does factor. We need two numbers that multiply to negative 10 because we take 1 times negative 10 is negative 10 and add to negative 9. Well, it's going to be 1 and 10. 1 times 10 is 10, except we got to make the bigger one negative because 1 minus 10 is negative 9. This is the pair of numbers. If x squared is by itself, we have a shortcut. The shortcut, you can use the shortcut. What's the shortcut? It's going to be x plus 1, x minus 10. And then it's going to be divided by x plus 5. Okay. So in our answers, that's what we're going to put. So let me stop sharing here and start sharing the homework so that you can see how we enter it. So to factor this, it's going to be x plus 1, x plus 1 times x minus 10, all divided by, except they're going to be mad. So let's just do x plus 1, put the divided by, because then we can go back up. X minus 10 divided by the x minus 5. All right. Are they happy? They weren't happy. Are they not happy because I put a capital X? X minus 10, x plus 1. Oh, because you see on the bottom, it's x plus 5, not x minus 5. There we go. We got it. Third check, we got it. This is what we want to do next now. Find the domain, okay? So domain, yes, that's correct. Yeah. Jordan, that's true. I'm just pausing it. Yeah. So it's not going to be a bunch of different videos. It's just going to be one, because at the end, I'll just stop. Yeah. All right, so now let's go back and we'll go find the domain, right? So we're going to share again. And to find the domain, right? In a rational function, you cannot divide by 0. So to find the domain, you set the denominator to be not equal to 0. So that means x plus 5 can't be 0. So to solve that, just subtract 5 on both sides. X cannot equal negative 5. Okay. The domain and the vertical asymptotes are related. The vertical asymptotes is where the domain isn't. Together, they're the complement. They do everything. So the domain are all values of x such that x is not equal to 5. So all real numbers except 5. The vertical asymptote, the difference is you set the denominator actually equal to 0. So the vertical asymptote is going to be x equals negative 5. All right, so let's go back to the homework and put those answers in. Okay, we're going to put those answers in. So, and not only that, anytime it's a rational function, anytime it's a polynomial divided by a polynomial, it's either going to be the domain is all real numbers or it's not equal to. So it's not equal to negative 5. All right. It should ask us for the vertical asymptotes next. Right? F of x in lowest terms. We already did that. Well, the questions are a little bit confusing because is it referring to the one we just did or? Well, that's fine. It's still not going to get mad because it still should be thinking of it as addition or as multiplication.
It is referring to the one you just did.
So we would say it's in lowest terms.
Yeah.
Perfect. Thank you. So find the intercepts. All right, let's find the intercepts. So to find intercepts, let's stop sharing here and reshare. Actually, you know, I probably don't have to stop. I could probably just reshare. All right, so let's find the intercepts. And let's move our function. All right, we're going to move our function down here. Oop. And we'll just set y equal to. And so, or that's our function, right? So to find x-intercepts, that's when y equals 0. We also call these zeros. We call these zeros. Why do we call them zeros? Because the y is 0. How do you find them? And it's really nice. To find the vertical asymptotes, you set the denominator equal to 0. To find zeros, you set, let's just write this out so it's all together nice. To find the zeros, which are also called x-intercepts, you set the numerator equal to 0. And I'll show you why. I'll show you why super fast. Because if 0 is equal to x plus 1, because we're plugging in y equals 0, times x minus 10 divided by x plus 5, your first step is to multiply both sides of the equation by x plus 5, which it will always be the first step. You always want to multiply by what you're dividing by. But what's always going to happen? Well, on the right side, the denominator and what you multiply by will cancel, and 0 times anything is 0. So you're going to get 0 equals x plus 1 times x minus 10. You set each one individually equal to 0. Either x plus 1 equals 0 or x minus 10 equals 0. So we're going to subtract 1, x equals -1, or add 10, x equals 10. We have 2 intercepts. So these are the x values. So we get -1 and 0, and we get 10 and 0. All right, so let's put those answers in our homework. Can you guys see the homework? Yes, we can. All right, perfect. So let's put those in. So the graph has, well, it has x and y intercepts. So we found the x-intercepts, which were 1 and 0, and then 10 and 0, except one of those has to be negative, which is probably this one. It's -1, 0. Okay. Let's double check. We're going to go back to the other screen and double check. It was -1 and 10. So that's how we find the x-intercepts, which we also call zeros. To find the y-intercepts is really nice. The y-intercept is when x equals 0. So if x is 0, we'll just plug it in. If x is 0, we get y equals 0 plus 1 times 0 minus 10 divided by 0 plus 5. Well, depending, it's not super nice, I guess. So that's y equals 1 times -10 divided by 5. Well, that's -10 divided by 5. That's going to be -2. So that point is x is 0 and y is -2. So we'll put that in our homework. All right, so then over here we have the point 0, 2. Those are intercepts. How'd we do? Not good. The graph has y-intercept. The y-intercept 0, 2, and x-intercepts. I don't know, am I entering them wrong? Who can see it? Did I mess up the sign? Let's go back.
Yeah, I just want you to put the actual y equals or x equals.
Oh, they don't want it as an ordered pair? All right,
Yeah,
these
no.
are good things to know. So they don't want it as an, wait, yeah, they don't want it as an ordered pair. So we're going to write y equals 2. All right, y equals 2.
Although
then-
they just want -2 and -1 and 10.
Oh, all right, even worse. That's fine. 2. I'm hoping that if you do something like that on the test, your instructor will see. That's not always true. And like mark it right. So that's what they want. Wait, was it 2 or -2? I can't see my work.
It was
It
-2.
I got you. So wait, which one did I mess up?
Yeah, -2. That's right.
Is that what I had? It's okay. We don't have to be perfect about entering. They'll tell us when we're wrong. Oh, we weren't. All right, perfect. Determine the behavior of the graph at the intercepts. Select the correct choice. So the graph will cross. Okay, so this is with the polynomials. So let's talk about this, where it crosses and oh, thank you, Kip. Where it crosses or bounces. Okay, so let's go back to our original, and this is going to go back to polynomials, which we didn't talk about today. But let's go back to this right here. We're looking at this right here. Okay. Remember, if it's an exponent, if the exponent is odd on the zero, it crosses. If it's even, it touches or bounces. I prefer bounces because bounces is more what it does. So on every single one of these, it's going to cross. Because what's the exponent on each one of these factors? Each one of these multiples? It is 1. So it is going to, so we're going to share, and then we're going to put that in. The graph will cross at oh, and we're just talking about the intercepts. So it's going to cross at 1 and -10. Did I put that in right? Probably not. Let's go back and see what they actually were. It's -1 and 10. Sorry, -1 and 10. It'll cross at both of those. All right, determine the vertical asymptote if it exists. The vertical asymptote is where the domain isn't. We found that, and you can go back up to where the domain is, right? It's going to be x equals -5. So the function has one vertical asymptote at x equals 5. Or it was -5, right? Is it going to be mad if we'll find out. We might just put -5. Good, they liked it. Determine the behavior of the graph on either side of the vertical asymptote. So, man, all right. They love lots of problems. So what we're going to do is reshare the screen. Okay. And we're going to clean everything up. We're going to clean it all up. We're going to grab just this. Oh, sorry. We're going to grab just this. Put it up here. And actually, we're going to cut that. Select all. We're going to move this over here. All right. So at -5, what we can do is plug in -4 and see what we get. And then plug in, well, -4 is actually bigger. We will do it, but it'll be on the other side. We plug in -6 and we plug in -5. What happens if we plug in -6? We get -6 plus 1 divided by times -6 minus 10, -6 plus 5, right? You can use a calculator too. That's absolutely fine. So we get -5 times -16 divided by -1. 3 negatives make a negative, which means that on the left, this is going to go down to -infinity. As you approach it, going left to right, it'll go to -infinity. And then because the exponent here is 1, it's going to do the opposite and go to infinity afterwards. So if we're looking at the -5, so if we have a coordinate plane, and this is our asymptote at x equals -5, our graph is going to go down, follow this down, and afterwards it'll start up. That's kind of the shape of what it'll look like. So let's go back and plug that in. I know this might not be super helpful because we're going so fast, but hopefully we'll have access to that recording somewhere. So we're going to go back to this. All right. It approaches infinity on one side and -infinity on the other. That is true. It approaches either -infinity on both sides. What? All right, we got to read. It approaches -infinity on both sides. That is true. It approaches infinity on one side and -infinity on the other. Ours does negative infinity. What is the difference between these? My math lab's wonderful. It approaches infinity on one side of the asymptote and negative infinity on the other. It approaches either infinity or, oh, because that would be there's two asymptotes. This is there's one asymptote. Okay, so I think ours is C, because ours and our asymptote is x equals -5. Boy, they made that pretty complicated to figure out. Let's see if we got it right. All right, we did. All right, so the horizontal asymptote, this is the last thing that I wanted to talk about. I wish we would have gotten there a little bit faster, but if you need to go, right, obviously this is all. So to find the horizontal asymptote, there's three cases. So we didn't have to do any of that, just so you know. You didn't have to plug in those numbers. You know, because the exponent is 1, you know that it's going to cross. And what it means to cross is one side is going to be negative infinity and one side is going to be infinity. When it's an even, that's when they're both going to be negative infinity or they're both infinity if it was even. So you didn't have to go all through that work to do that one. All right. Let me share the work we just did. Okay, so to find, and I believe they're asking for end behavior on this one. Well, to find the horizontal asymptote. Okay, you go back to the unfactored form. The unfactored form is x squared minus 9x minus 10 divided by x plus 5. You look at the degree of the top. The degree of the numerator is 2. The degree is the highest power of x. Highest power of x. The degree in the denominator is 1. There are three cases. Ours is the degree of the numerator is greater than the degree of the denominator. Anytime this is the case, it's an oblique asymptote. It's an oblique asymptote if the degree of the numerator is greater than the degree of the denominator. So what we are going to do, hold on, I clicked on something it didn't like. There we go. I got to go to the left and then we're good. So what we're going to do is we're going to put in, it does not have a horizontal. If it has oblique, it doesn't have horizontal. So it has no horizontal asymptote. This one has an oblique. The function has one oblique. And how do we find the one oblique? We're going to use polynomial division. Anytime the degree of the numerator is greater than the degree of the denominator, we use polynomial division. So we're going to take x squared minus 9x minus 10 and divide it by x plus 5. All right. To do polynomial division, take the first term on the inside divided by first term on the outside. X squared divided by x is x. Put that on top. Distribute to the outside. X times x is x squared. X times 5 is 5x. All right. This is my favorite step. Switch the sign of each term. If it's positive, make it negative. If it's positive, make it negative, then add. X squared minus x squared is 0. Negative 5x minus 5x is that's negative 14x minus 10. Then you repeat those steps. You're going to repeat those steps. You're going to have negative 14x divided by x. Well, that's minus 14. Distribute to the outside. Negative 14x minus 70. Something like that. Then switch the sign of each term. This becomes positive and positive. When we add, we get, well, those cancel. We get 60. Now, when we try to divide, take 60 divided by x. That cannot be done. So we're done with the problem. When you can't divide, you're done with the problem. And your answer is up top. Your answer is y equals x minus 14. Your answer is y equals x minus 14. Okay. What I am going to do, okay, I went through it too fast, but I'm going to give you a video. I'm going to give you a video of polynomial division. In fact, I'm going to give you two videos. One video going over the different cases, because there's 3 different cases. And one video for, well, I lied. I'm going to give you 3 videos. Copy. This is, I'll call it case 1. So in the chat box, and we'll put in the answer. We're pretty much done now. So this is going to be the case 1. That's the easiest case. That's when the degree of the numerator is less than the degree of the denominator. The answer is y equals 0. It's the nicest case by far. Case 2 is also okay. It's not a super ton of work. And case 2 is when the degree of the numerator is the same as the degree of the denominator. And then case 3, which is one we just did that I went through way too fast. That is case 3, polynomial division. Okay, so those 3 videos, please, please, please watch those, go through them. I actually write out the steps in the videos too, which I would have done it had we enough time. I would have written out the steps of polynomial division. But that is important. That is important. Okay, let's share. Let's go back and share. Wait, what am I on? That's okay. There's one oblique asymptote and we found it. It was x minus 14, but you got to put in the y equals x minus 14. Let's check it. There it goes. We got it. Holy moly, there's still more. All right, unbelievable. Determine the points, if any, at which f intersects the horizontal or oblique asymptotes. Okay, we're just going to say it doesn't intersect, although it probably will intersect. How do we do that? We set the 2 equations equal to each other. So let's reshare and set the 2 equations equal to each other. What a terrible question. All right. How would we tell when they intersect? You set these 2 equations equal to each other. You set this equation equal to this equation. So it's going to be x minus 14 equals x squared minus 9x minus 10 divided by x plus 5. Then multiply both sides of the equation by x plus 5. On the left side, you have to FOIL. We're going to get x squared minus 14x plus 5x minus 70 is equal to x squared minus 9x minus 10. Subtract x squared from both sides. It's kind of nice because it's not quadratic anymore. And so we end up with negative 14x. Oh, negative 14x plus 5x. We can do that. That's negative 9x minus 70 equals 9x minus 10. Perfect. Add 9x to both sides. This is perfect because is negative 70 equal to negative 10? No. So that means they never intersect. So let's reshare. This really isn't that important in the grand scheme of things, but it is on our homework. There is no point. Perfect. Use the real zeros in the numerator to divide the axis into intervals. Determine where the graph is above and below. So we need to do a sign chart anyway. We need to do a sign chart anyway. All right. We are so far out of time. We are not going to do a sign chart. We're not going to do a sign chart. Should I show you how to do sign charts though? I have a video for it. Guys, I have videos for everything. All right. So let's do a sign chart. And I like my videos. If you don't like my videos, that's fine. You don't have to use them. but I will show you how to do a sign chart. It'll be on a polynomial, but the same is true for a rational function. The same is true for a rational function. So the last video I'm going to post, and again, you guys are always free to come and go as you please. But I did want to show one. I did want to put the video for a sign chart. Sign charts are super important. All right. I am curious. Oh, no. Oh, no. It's a long lecture. It's a full lecture. Oh, no. I have a full lecture. I don't have a. Well, I'm going to give it to you just because. I have the full lecture over polynomials if you want it. I didn't break them up into small videos. I'm sorry. Except I need to click on this and then copy paste it. All right. There we go. And this is actually polynomial lecture. But there is, if you go through it, there's what I call a sign chart, which is the last problem in there. All right, we're going to pause the recording here. Should have ended a little bit